Lesson 9.6 is all about solving rational inequalities and equations. Now, we've been working with just the expressions before, but now we're going to be working with actual equations and inequalities as far as how they interact with each other with our fractions or with our ratios, the rationalness to them. So we're going to break it down first and look at just a fraction, which is kind of like a rational equation. So if we said 1/2 plus 1/3 equals x over 6. So it's a fractional equation because it only involves these fractions, but it's very close. It's pretty much the same as a rational equation because we have essentially polynomials in the numerators and in the denominators. Now to solve this out, we still have to find the least common denominator, the LCD. And how we do that is we separate out all the prime factors. So 2 just becomes 2, 3 becomes 3, and 6 becomes 2 times 3, which means our LCD in this case is 2 times 3, or 6. So what we can do with that is multiply each piece by our LCD. Multiply it all by 6. So we're left in the end with 6 times 1 is 6 over 2, plus 6 times 1 is 6 over 3, equals 6 times x is 6x over 6. Now at this point, we can just divide everything through, or essentially cancel them out. So 6 divided by 2 is 3, 6 divided by 3 is 2, and 6x divided by 6 is just x. Now, it's just a normal kind of regular equation that we can just spell right out. 3 plus 2 is 5, so 5 equals x. And that's how we would solve that. So we would say then that 1/2 plus 1/3 equals 5/6. So that's the main basic concept. Let's see if we can apply that to our rational equations. So again, our steps were find the LCD, multiply everything, each piece, by the LCD, solve for x, and now we also have to check for x and make sure that it works for each piece. We might get a couple of answers that when we plug them back in, like in this case, if our x came out to be 3, we would say that's an extraneous solution because 3 minus 3 equals 0, and we can't have zeros in the denominators. So let's go ahead and find the LCD. First things first. 24 breaks down into, let's say 24 is 4 and 6. 4 breaks into 2 and 2. 6 breaks into 2 and 3. So we would say that prime factorization of 24 is 2 to the 3rd power, 2 cubed, times 3 to the 1st power. Our next denominator was 3 minus x, which actually just stays 3 minus x. That's as low as we can factor that. And our last one is 4, which 4 breaks into 2 and 2, so we'd say it's 2 squared. So it looks like all of our factors are 3 minus x, 3, and 2. 2 happens a couple times here. So we take 2 to the highest power is going to be 2 to the 3rd, times 3 to the highest power is 3 to the 1, times 3 minus x to the highest power, which it only happens this once, so it's times 3 minus x. This is going to be our LCD. If we simplify it a little more, 2 to the 3rd times 3, our LCD is actually just 24. Oops, this is a 3 minus x. This is our LCD then. So I'm going to take all of this. Oops. We'll just shrink it a little bit, put it off to the side. So we know 24 times 3x is our LCD. So we times everything by 24 times 3 minus x. So that would give us 24, 3 minus x, times our first piece was 5 over 24. That was our first equation there, plus 24, 3 minus x, 2 over 3 minus x, and it equals 24, 3 minus x times 1 over 4. Now from here, all we have to do is divide things out, 24 and 24. Here we have 3 minus x and 3 minus x. Here are 4. You can divide out with our 24, so this just becomes 6. So in the end, we would say, if we distribute this 5 right away, we would have 15 minus 5x plus 24 and 2, 48, equals 1 times 6 is just 6, 6 times 3, 6 times negative x, give us 18 minus 6x. Now this is the equation we're looking to solve, which is a lot cleaner than our original one. From here, we can just kind of pool everything together, combine our like terms. So we would say then 63 minus 5x equals 18 minus 6x. I'm going to add 6x to both sides, and subtract 63 from both sides, which means in the end we're left with 1x, or just x, equals negative 45. So as of right now, this is our only solution, but we need to check it and make sure. So the only place it comes up is right here, 3 minus negative 45. We can't let that equal 0. Luckily for us, that equals 48. So it works. Put a little check by it. It worked. Good job. That is our answer. So if we try this one again, in this case, we have a little more complex of our rational expressions. This one, we still need to find our LCD first. Remember, that's always the first thing we do. So it looks like this just factors down into p plus 1. This piece factors into p plus 1, p minus 1, because it is a difference of squares. We're actually going to call this piece p over 1, in which case our denominator is just 1, so we'd say our factor is 1. Now, looks like our LCD, we just have to take all our factors. Each one has a p plus 1, so we'll put in p plus 1. And as well, there's a p minus 1. So this is our LCD. It's p plus 1 and p minus 1. So I'm going to get rid of these pieces. We need to multiply each piece by our LCD. So we would say then, start over here, p plus 1, p minus 1, times the original part was p squared minus p plus 1, all over p plus 1. That's our left side of the equation. On the right side, we have, again, p plus 1, p minus 1. Oops. I'm using the square bracket, so I know that these were my pieces from the original. So p squared minus 7 over, I'm going to factor this piece right away, call it p plus 1, p minus 1. There we are. Then we need to say plus p plus 1 again, p minus 1 again. Our original piece was p. Our original denominator was 1. So that is what our equation looks like. So it kind of looks like it got a little more messy, but we clean it up a little bit. Take rid of our, or get rid of our p plus 1, get rid of p plus 1, p minus 1, and just get rid of that piece. Now things are starting to look a little more clean. We can break it down into just this p minus 1 times p squared minus p plus 1. This piece is just p squared minus 7, and this is just going to be these three pieces together. But nice trick for this is, remember this p plus 1, p minus 1. From our original equation, this is p squared minus 1. So it's actually only this piece and our p. So Now we need to clean things up even a little bit more by double distribution here. So p to each of these and -1 to each of these. So this one might take a second here. P to all of those would be p cubed minus p squared plus p. -1 to all of those would be negative p squared plus p minus 1. So that is the left side of our equation. The right side, we still have this p squared minus 7. And over here, if we distribute the p to each of these, so we'd have plus p cubed and minus p. So now this is our equation. It's starting to get a little more clean. Now we just combine some like terms. So actually, let's subtract some things out. We'll take out p cubed and p cubed. We have a plus p over here and a minus p over here. Actually, we can't. What am I thinking? Those are the only ones that can actually really cancel out. From here, we'll combine all these like terms. So this becomes minus 2p squared. That was from here and here. This is plus 2p from here and here. And minus 1 equals p squared minus p minus 7. Okay, everything is accounted for. Now, from here we can say we'll subtract, oops, I'll use a different color. Subtract p squared, add p, and add 7, add 7. There, now that is all legal. This gives us negative 3p squared plus 3p plus 6 equals, well, all of these canceled out on this side, so we now have equal to 0. At this point, we can take negative 3 out of the equation. That's our greatest common factor. We're left with p squared plus p plus 2 equals 0. Now, at this point, we need to factor a little bit further. We'd say negative 3 p plus 2 p minus 1 equals 0. Perfect. Now from here, we would say the only way for this to happen is if p equals negative 2 in this case, or if p equals positive 1 in this case. So these are our two possible answers, but we need to go back to our original equation and check those. So we have negative 2 and positive 1. Negative 2, positive 1. Let's check those. If it was positive 1 right here, 1 plus 1 is 2, that's okay. If it was positive 1 right here, 1 squared is 1, 1 minus 1 is 0, that's not okay. That doesn't work. Now we'll try negative 2. Negative 2 plus 1 is negative 1, so it works. Negative 2 squared is 4. 4 minus 1 is 3, so that works. So the only one that works is p equals negative 2. That is the only solution to this equation.